Okay, today we are going to discuss some examples in HK Das. Okay, now the first question is form the differential equation by eliminating arbitrary constants in the following cases and also write down the order of differential equations obtained. So the first question is y is equal to ax plus a square. Now we have to eliminate these arbitrary constants. So first we are differentiating both sides with respect to x. So we will get dy by dx is equal to a. Okay, so the value of a is dy by dx. Now substitute this value of a in this equation. We will get y is equal to x dy by dx plus dy by dx the whole square. Now what is its order? Order is 1 because it is the highest differential coefficient. So order is 1. Okay, now the next question, y is equal to a cos x plus b sin x. So differentiating both sides with respect to x, we have to differentiate 2 times. Okay, so when we differentiate first time, we'll get minus a sin x or a times minus sin x plus b cos x. Now differentiating it once more, we'll get d square y by dx square is equal to minus a cos x plus minus b sin x. Now if you notice this is actually the negative of y, right? So we can write d square y by dx square is equal to minus of a cos x plus b sin x, which is equal to minus of y. D square y by dx square is equal to minus y. Now taking this minus y to the LHS, we will get d square y by dx square plus y is equal to 0. Now what is the order here? Order is 2. Now the next question is y square is equal to ax square plus bx plus c. So first we will differentiate both sides with respect to x. We will get 2y dy by dx plus 2ax plus b. This constant c will go. Now again differentiating it both sides with respect to x, we will get 2 times dy by dx the whole square plus 2y d square y by dx square is equal to 2a. This b constant b will go. Now we can take out 2 common and cut it. Then so here after rearranging this equation, we will get y d square y by dx square plus dy by dx the whole square is equal to 2a. Now again differentiating, we have one more constant left here, so we have to differentiate again to remove this constant. So it will become y is equal to d cube y by dx cube plus dy by dx into d square y by dx square plus 2 into dy by dx d square y by dx square is equal to 0. Now if you notice this, the second and the third term, they have different coefficients but the variables are same, so you can add it. Now the equation becomes y into d cube y by dx cube plus 3 dy by dx times d square y by dx square is equal to 0. Now this is the differential equation for this question. Now what is the order here? Order is 3 because it is the highest derivative here, d cube y by dx cube. Now the second question is determine the differential equation whose set of independent solutions is e raised to x e raised to x, comma x square e raised to x. So according to differential equations properties, we can write the general solution as y is equal to c1 e raised to x plus c2 x e raised to x plus c3 x square e raised to x. This is our equation number 1. Now to find the differential equation, we have to eliminate these arbitrary constants c1, c2 and c3. So first we have to differentiate this equation with respect to x. So we'll get y dash is equal to c1 e raised to x plus c2 x e raised to x plus c2 e raised to x plus c3 times 2x e raised to x plus c3 x square e raised to x. Now on rearranging these terms, we'll get y dash is equal to c1 e raised to x plus c2 x e raised to x plus c3 x square e raised to x plus c2 e raised to x plus 2c3 x e raised to x. Now when you consider the first 3 terms and look at this equation number 1, we can write instead of these first 3 terms as y. Okay, so it will become y dash is equal to y plus c2 e raised to x plus 2c3 x e raised to x. So the first arbitrary constant c1 is gone now. Means it is not gone directly. Here we eliminated it, just think like that. Now differentiate this equation with respect to x, because we have two more arbitrary constants. So we'll get y double dash is equal to y dash plus c2 e raised to x plus 2c3 x e raised to x plus 2c3 e raised to x. Okay. Now from equation 2, from this equation we can write y double dash is equal to y dash plus y dash minus y plus 2c3 e raised to x. Okay. Now just adding these two terms, first two terms, y double dash is equal to 2y dash minus y plus 2c3 e raised to x. This is our third equation. So the second arbitrary constant is also gone. Now differentiate this third equation with respect to x again. Okay. So y triple dash is equal to 2y double dash minus y dash plus 2c3 e raised to x. Now from the equation 3 we can write y triple dash is equal to 2y double dash minus y dash plus y double dash minus 2y dash plus y is equal to 0. See, from the equation 3 we can write 2c3 e raised to x as y double dash minus 2y dash plus y is equal to 2c3 e raised to x. We can write it like that. So and substitute for 2c3 e raised to x. Okay. Now add the terms 2y double dash and y double dash, then minus y dash and minus 2y dash. You will get the equation as y triple dash minus 3y double dash plus 3y dash plus y is equal to 0. Now this is the fourth equation. Now also we can write that equation as d minus 1 the whole cube y is equal to 0. Here d stands for the differential operator d by dx. So we can write it like this: d by dx minus 1 the whole cube operating on y is equal to 0. Now just expand this LHS. Okay, just expand this LHS. We will get d cube by dx cube minus 3 d square by dx square plus 3d by dx minus 1 all operating on this y. Now after this operation you will get y triple dash minus 3y double dash plus 3y dash minus 1. This was the LHS of our answer. Now the third question is, by the elimination of the constants a and b, obtain the differential equation of which xy is equal to a e raised to x plus b e raised to minus x plus x square is the solution. The solution is given. From the solution we have to obtain the differential equation by eliminating the arbitrary constants. So rewriting this equation, xy is equal to a e raised to x plus b e raised to minus x plus x square is equal x square. This is the equation number 1. Now differentiate this equation with respect to x. We'll get y plus xy dash is equal to a e raised to x minus b e raised to minus x plus 2x. This is the second equation. Now again differentiate differentiate this second equation with respect to x. Okay, so we'll get y dash plus xy double dash is equal to a e raised to x plus b e raised to minus x plus 2. Now in the next step we can add these y dashes. We'll get 2y dash, and from the equation 1 we can write a e raised to x plus b e raised to minus x as xy minus x square. Okay, so the equation will become 2y dash plus xy double dash is equal to xy minus x square plus 2. Now bring this xy to this side. We will get xy double dash plus 2y dash minus xy is equal to 2 minus x square. Just rearrange the equation. So this is our answer. This is the differential equation for this solution.